You are listening to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the advancing journeyman developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Good morning, object-oriented developers. This week, we're discussing how the interactions between object-oriented programming and relational databases go bad. Since Will is going to be talking about this at DevSpace, we thought it would be a good fit for an episode, and he wants to hit on some of these points again. But before we get started, Will, what have you been fighting this week?
Database triggers. I think I was probably doing this last week. We recorded. So we had like 40 tables that the triggers were just recording inserts and updates, and they weren't recording. A lot of them weren't recording who did it, what application name did it, those kind of things. And they weren't recording any deletes. And so I basically wrote a script that generated all the triggers I needed and did all the things. I had to fix a whole bunch of fields. And then of course we have Entity Framework stuff sitting on top of that. And so now I've gotten it to the point where everything builds and I'm going through the app and spot patching all the places that are broken. The previous developers put POCO objects, plain old class objects, instead of the EF objects. So it was like a repository over unit of work pattern, which is never a good idea. As a result, I find a lot of errors at runtime right now.
Plain old object pattern.
Yeah, so it's like you take let's say you have a table that's person table, you get a person object out of that. Well, because Entity Framework, it maintains all the session, it basically extends the object and does a bunch of crap to it, and it's tied to that session. And if you are trying to save an instance, you've got to make sure it's on the right session and
I've had that problem before.
Janky crap with it. So what we do is we just project that into another object that's decoupled from it. And that object serializes properly. There's no surprises. It's not, some other type that's extended. It just does its thing and it can come back in that way. And then we reproject it, right? That's how a lot of the CRUD pieces of the app work. Now we do have some stuff that's starting to get into command query responsibility segregation, but we're not there yet. As a result, when you change column names in the database, you're changing what's projected back out, but we're using AutoMapper and it maps fields to fields. Well, you change the field name now, there's no map and stuff is getting nulled. And so I'm having to find all those as I'm going through. And so it's just taking a little while. That, and I finally got fed up with IIS Express today and switched over to straight IIS for my development.
Really?
I just couldn't take it anymore. It was like, it would get a request and it would just sit and spin. Like I literally left it this morning spinning for an hour while I was in a meeting and it never came back, never errored. Wow. Nothing was logged. It was still chewing through CPU. There's some kind of config thing. And I finally was just like, all right, well, this isn't going to work. We have some things going on under the hood that are kind of weird. So it doesn't really surprise me. We probably should have switched it, but yeah, I've been fighting that on top of everything else.
That sucks.
Yeah. So how about you?
Well, some insult here because I probably called them that. Got the bright idea to change the default settings on Emmet in VS Code. So when I updated last night, suddenly what worked before updating didn't. It's been a few hours trying to figure that out when I finally came across an issue in GitHub about making sure the settings were correct. Now, it's always been set one way as the default.
Right.
It's basically the default had always been where you tab to expand. Right. And they set that to false because now they're including it in the drop down, like when you hover over it.
So as a carriage return to do it?
No, carriage return doesn't do it. You have to go in and change the setting manually in the settings.json to allow it. Set that to true.
I guess I kind of get that. Like if you're typing something that's not in that drop down and then you hit tab, you want to get away from it, but it's still, I don't know. I don't like breaking existing settings for people because usually people kind of get into a workflow and they get faster. And if you yank that out from under them in the middle of something, it just, I made my opinion clear on GitHub politely.
after.
You didn't do like that dude did on the VS Code thing?
No.
that poor kid that like he lost like what 3 months of work
Yeah.
because of the way the Git integration worked and some misunderstandings there. He just like blew away 3 months worth of work and then just started dropping F-bombs on the VS Code people.
Yeah.
That was great. That's it's like, you know, how do you make sure that everybody knows that you don't want to be employed?
So my comment was, why did you make this change when it has been the exact opposite since the beginning? I've been using Emmet with VS Code ever since that came out. Like before it was part of VS Code, when it was an extension you had to install, I was using it, and the default has always been expansion on tab.
So it's not an extension now?
No, it's part of VS
built
Code.
in?
Yeah,
Okay.
it's built in. You can get more extensions there. The response I got, which I did get a quick response, the response I got was to a blog post about why the changes were made. And I saw that. I still think that it was a bad idea to make those changes, make that available to turn that off. But changing the default setting.
Well, it's almost like they need to have a pop-up that just says, hey, this has changed. Which way do you want it?
Yeah.
And then go forward from there. Because otherwise, you know, like I know they want to move forward on things, but that's probably the way that you would handle that. I have been really impressed with the VS Code team.
Oh yeah, I
just
have.
like kicking out a release every month, and you know, just the amount of stuff they do. Like they're doing the right things on average.
In general, I'm not complaining about VS Code. I'm complaining specifically about Emmet, and I really like what they're doing and the changes they're making in version 2 to make it more modular. But it's changing my default settings.
Yeah.
That's not a good idea.
Yeah, people that are outside of tech don't realize just how,
Yeah.
I mean, like if you're down in there typing all day, every day and like trying to work, it's like somebody, taping your thumb to the inside of your palm and then telling you, oh yeah, go ahead, you can drive these nails in.
Yeah.
And you're going to be messed up. Yeah.
And the other thing too is, because I've got the new laptop, I wasn't sure. Oh, did I not does Emmet not come with VS Code anymore? Do I need to go install the extension? 'Cause, like, it just wasn't working. Like I hit tab and it just tabbed over, and I'm like, wait, no, you know. And so I spent a lot of time wasted trying to solve the problem that wasn't a problem.
Yeah.
You know, I thought something was broken and it was doing what it was supposed to do.
Yeah, that's always the worst.
And apparently it came out, it was in the release notes that they did that, but like there's 50 million things in those release notes. Who reads all that?
I do. Because I've learned, like, you don't let anybody touch your IDE until you read the release notes. Just some early Visual Studio experiences led to that personal.
I've learned my lesson the hard way. On a happier note, I finally replaced my truck. It feels good to not be borrowing a car. You don't
feel like a teenager anymore.
Yeah. I didn't quite get enough money from my insurance to buy a decent truck. Yeah, they tend to retain their value, but right now trucks are selling for more than they're worth. So I bought a new car. I'm going the DMV for Davidson County is downtown. So when I'm in the office, I'm going to be going down there. It's just a short walk for me. Now, yesterday, Will and I went over to a friend's writing group. That was a bit fun.
Yeah.
Not sure how much we actually got accomplished.
Well, we do know, because you got a book chapter outline and I got a show outline.
Yeah, well, I should say, I don't know how much we could have gotten accomplished, because being the new guys, we tended to do a lot of talking and getting to know you activities. Well, activities, chatting, really. So, but with all that said, we've kind of gone a little long for the intro, so let's get on into some IoTs. This week for IoTs, I have an interesting product called the Air Quality Egg. This little egg is an open source project that has been built to measure the air quality within a community. It monitors pollution levels and collects and shares the data with other devices. There's a mobile and a web interface for viewing the data. It measures different levels of carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen dioxide, and other volatile organic compounds. Pulled all those from their website. The eggs are Wi-Fi enabled, so you can hook it up to your Wi-Fi and it'll collect and share data with other eggs in your area, or you can create a network of your own eggs or interact with others in the same community all around the world. I'll have a link to that in the show notes. Who's talking to us this week?
We got a email from Milos. It says, "Hey guys, I just wanted to give you a quick shout out for doing an awesome job with the podcast. I work as a business analyst, product owner in the tech industry, and your podcast was one of the main reasons why I started to build up my technical skills. I started learning C#, Git, and even created my blog page with Jekyll and GitHub, where I will be writing my progress. I will also share some of my knowledge and experience from the industry and build up my resume and portfolio. I also have a podcast section where I listed you guys as well. You can check it out here, and we'll put that link in the show notes. Again, thanks for the great podcast and motivation you're providing. Can't wait for the next episode."
Well, thanks, Milos. We appreciate the compliment and the mention on your site. Like Will said, we're going to include that in the show notes so that everyone can share in the shows that you enjoy. We've both known quite a few people to make the switch from business analyst to developer. You have a little bit of a benefit already knowing a lot about the process that developers without your experience have to learn once they start working. The hard part, I feel, for you is going to be when you're ready to get your first job as a developer, because some places will see that BA experience and kind of want to pigeonhole you into those kinds of roles.
Yeah.
And I want to caution you, I guess, a little bit about that in being firm about wanting to make that transition. Don't let yourself get put into a position where they say, "Oh, you're going to be a BA, but we'll let you do some development," if what you really want to do is be a developer.
Right. I would agree with that, because I've seen that happen quite a few times. Mm-hmm. Just, it's not that good.
But please keep us updated with your progress. In the meantime, send us another email with your contact information, because we've got a complete developer water bottle just for you. And guys, if you'd like your own complete developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, LinkedIn, Twitter, and Google+. We're also on Path and Tumblr. This episode came about as Will was preparing for his talk at DevSpace. We'll both be down in Huntsville, Alabama on October 13th and 14th for North Alabama's premier polyglot technology conference. You guys can get tickets now and use the code COMPLETEDEV so that you'll get a 10% discount. Come down to hear Will speak and stop by our booth to say hi to both of us. Again, that's DevSpace in Huntsville, Alabama on October 13th and 14th.
Your database is often the most important part of your application in terms of actual value to the business. The value of the database will only increase over time as long as it is adequately maintained. Your database administrator is in charge of this maintenance, and you'll often find that the constraints under which they are operating are very different than yours. If you don't play your cards right, you'll often find that the database administrator quickly gets in the way of all that object-oriented programming goodness that you enjoy so much.
Never happens. Ever.
Yeah.
Sarcasm, guys.
Yeah. It hasn't happened to you in, like, say, the last hour.
Yeah.
Because you've been here.
So what's the deal with object-oriented programming and databases?
Well, it's often been called, if you talk about object-oriented, mapping, object relational mapping, or the impedance mismatch, it's often been referred to as the Vietnam War of computer science.
And the DBAs are the Viet Cong.
Or you are to them. But every so often they roll out a little Tet offensive about data integrity.
And we are... I got this. And we are Robin Williams' character. Good morning, Vietnam.
Yeah. In all seriousness, there's a pretty significant mismatch between how databases work and how object-oriented programming works. And there's really two main problems that come up. And the first is that calls to the database are typically over a network, whereas object-oriented programming code is typically local. So you've got remote procedure calls versus local function calls, and that's a pretty big difference in terms of performance and the constraints you have to deal with. Object-oriented programming is heavily centered around code reuse that is based on inheritance, whereas database operations are structured around projections of data and how data is stored.
So what is an object relational mapper?
Well, to go with a Vietnam War metaphor, I guess it's an exploded landmine. For everybody, right? Like it hurts whoever happens to run into it first. No, an ORM is basically a system for mapping tables and other database objects to objects in your code so that you can get data in, get data out. This lets you programmatically interact with the objects rather than dealing with SQL, which a lot of programmers find to be a lot easier because they tend to think in just one language.
Mm-hmm. That makes sense. And, there's also mapping generators. Like I use NHibernate a lot, and I use an NHibernate mapping generator.
Right, to do kind of an active record pattern.
Yeah.
Yeah.
And like with Entity Framework, it does a lot of that for you as well.
The older versions do. The newer ones, not as much because they realized just how bad of an idea that was. Mm-hmm. Because I've been fighting that quite a bit this last week. Typically, but not always, these ORMs will also integrate a unit of work pattern. So you can, pull a bunch of objects back, modify them, and then basically call a save command that has got the list of what changed and then pushes that into the database.
Okay.
All in one shot. They also tend to protect you a little bit more against SQL injection versus just doing straight up SQL code. Even though you can do parameterized SQL, this sort of does it by default under the hood where you don't have to think about it as much. Yeah. So that's one of the benefits of ORMs. That said, we did an episode a while back about why your DBA hates your ORM. And this was basically talking about how the impedance mismatch hurts them on the other side. Mm-hmm. Well, this time we're going to talk about how that impedance mismatch hurts you as an object-oriented developer.
So this is the converse of that one.
Right, or the inverse of the reverse.
It's some kind of verse.
Yeah, it's the opposite. It's the mirror image.
Well, getting on into it, most ORMs are built to enable CRUD, or create, read, update, delete applications against tables in the database.
Right. And this is simple, right? Because metadata about tables is the easiest thing to get. Mm-hmm. Because every database is going to have a lot of functionality for getting that, because otherwise the database itself has a hard time operating.
Exactly. It also matches the way that a lot of developers think about objects, basically bags of state optimized for implementing business logic.
And there's a lot of problems that we probably need to get into in a whole nother episode with that particular approach. But it's also very simplistic. It tends to be like a junior to mid-level developer thing, because you don't really get burned by this for a while until you're on an app that's a little bit older and you remember the decisions early on and have been around long enough to regret them.
I don't know. Sometimes you see stuff that other people have written and you're like, why did they do it that way?
Yeah, but when you wrote it,
yeah, well,
and you look at the source control and you remember, it's like, oh, I thought that I could just read out of this table into this object and then alter it and then put it back. Well, most apps don't work that way, right? That's not what you wrote the app for. Mm-hmm. But it's a very simplistic understanding. At the core of it, tables are basically bags of state, and that's why objects are based off of tables. That's why that makes sense early on.
However, tables are optimized for storage.
Right. You have an address. Okay, there's an address table because probably there's, previous addresses and all those kind of things, because they need to say, I don't want to store multiple versions of this thing. But, when I'm pulling it into an object, I probably only want your current address, except for, random, outside, edge cases. Most of the time, I just want the latest. So in an object, that would be, that's one level of an object. Whereas if it's in a database table, you've got your record, and then you have a one-to-many for all the different addresses. Mm-hmm. And so there, that's the impedance mismatch that they're talking about. And I know that difference is kind of subtle, but it gets rather profound the longer you do this, and especially from the OOP side, because people tend to try, on our end of things, people tend to try more and more clever hacks to get around this. which is why a lot of your ORMs are as nasty as they are to deal with.
It's also why the ORM has sort of a bias towards the direct table access.
Yeah, because that part's fun. And then once you get it out there, the other developers can deal with the problems.
Yeah. This also kind of hurts your DBA's efforts to optimize the database.
Right. And we talked about that a lot and why your DBA hates your ORM. And you can get to that episode if you want to take a look at that. And the best way to overcome this is not mapping types directly to tables. Map them to a projection of data, for instance, like a view. That way you're not hamstringing your DBA. You can reshape the data appropriately without taking a dependency on the table structure. You're just taking a dependency on basically what's an interface for the DBA, so that when they decide to change tables, it doesn't break your stuff, or they have a way to keep it from breaking your stuff because you're mapped to the view.
Well, it's for read, but what about for write?
You either do custom queries, store procedures, something along those lines that maps it. I typically do stored procs, to be 100% honest, instead of writing directly to it. Now, you can also do you can do writable views and actually set it up where if it gets the view data in, it knows how to put it in the tables that are underlying it. I'm not overly fond of that. I'd prefer to be explicit on things like that.
That's a bit. I'm funny about that.
Yeah.
It's just that this seems to defeat the purpose of a view.
Yeah. Well, the other thing too is I think that a read model being exactly the same as a write model probably indicates a lack of understanding of what's actually happening and what the intent is.
Mm-hmm. So ORMs often obscure the fact that calls happen across a network.
Right. And I'll give you an example. The code base that I work on at my day job, I recently found a chunk of code that was happening in the application begin request method in global.asax. We've got a web forms app. On every request, it was going out and saying, okay, here's my host name. Let me get the client ID that's associated with this host. It's multi-tenant. Cool. I've got the client. It gets the client record back, says, okay, give me the ID off of this client. Then it says, okay, now that I have this client ID, I'm going to go get the client settings. I get the client settings. It's a bag of state. It's like 100 columns. Big freaking object. You have no business pulling that whole thing across the network. Goes and gets it, pulls it back, gets a bit value off of it. It says, I can run in an iframe, or no, I can't, and sets a content header. That's it. So you have one call across the network to get the client record, pull it back, rehydrate it into an object, get the ID, another call back across the network to get the client settings, get it back, hydrate it into an object, then get a bit field and set a content header. When what you should have done is said, hey, here's the host name. Can I run this in an iframe? Ask the database and get that back. Right. But that looked like just object-oriented calls. So what happened is the person writing it wasn't in that head. They weren't thinking about, okay, well, this just looks like a regular function call, not, hey, I'm doing this over a network. I can't.
Yeah.
So, typically, like if you're using a unit of work pattern, which is, what Entity Framework and Hibernate, a lot of those use, you make a bunch of changes to an object or an object graph and then commit it. As a result, the objects that you're dealing with, they have to keep track of what's happened to them. So like if you have a person object and it's, coming off of a person table in the database because you did this, like the name property on there, usually what they'll do is they'll generate a wrapper around that object, or they extend it, through inheritance. There's different ways of doing this. When that call comes in to change the property value, it writes a record to some kind of storage locally. This says, hey, this has been changed from this to this. And it's basically keeping an audit trail live as it's going. So you got that little bit of overhead and the funkiness that can happen there. Because what if you updated it multiple times, and stuff gets out of sync, and all kinds of funky things can happen there. Now that happens as you're going, and you can commit in a batch, right? That's what the whole unit of work idea is. But certain operations, like let's say you add a new record and you need its primary key, like you added your activity,
right?
Like you said, okay, I added activity record, but this object over here has an activity ID instead of an activity object hanging off of it. In other words, I've got a mismatch between my object-oriented and my table-based structure, and I need that activity ID. Well, I got to get it from the database, which means I have to commit. Or I could hold a connection open and read uncommitted if I want to really screw up my performance.
Yeah, no.
Because you don't know how long it's going to take, right?
Right, yeah.
So you end up with things that it's like, oh, well, I need this value, but it's not blatantly apparent that I'm making a network call to get that value. So that's kind of what will burn you on that. And the other thing is it's also really difficult when you're doing this a lot of times to figure out what caused the additional traffic, because of that, like it's not going to be in there in your code. Go, oh, hey, make a network call to SP_ something. I've been troubleshooting, connection pooling issues, and that's another thing. We find thousands of calls that are basically, they're database calls that are happening across the wire, and it's not in my code. It's actually the constructor of a built-in object that's doing it. You just have to be careful about that, and it's really hard to trace that back down and go, okay, this is how my app is generating the excessive network traffic. And the DBA is going to be finding these things and coming to you, and you're going to look incompetent because you can't tell them what happened.
Oh, I understand. I have had those conversations.
And so the way I get around this is I try to reduce the amount of data manipulation that I do in my code. And instead I say, okay, here is the command I want you to do. Here's all the pieces you need, and then do it on the database side.
Okay.
And that doesn't necessarily mean enforcing business rules. Like, you enforce the business rules upstream before you pitch it to the database, and you'll make sure that you're not sending crap. But then you send it, and the database does all the table manipulation and all the underlying data manipulation, because, that language is specifically written for that, and it's close to the data where it's happening. So another thing that happens is that ORMs have a hard time with foreign keys. And there's a lot of reasons for this. Like, for instance, a database table may have an integer ID that's a foreign key to another table. But when you're dealing with an ORM, you want that object, right? Like you have a lot of issues around this. So you end up either accidentally pulling that object, right? Because, hey, this is in the graph of stuff I want to get back. Or you don't pull it, and then when you access it, it makes a call on your behalf over the wire. Like if you set up lazy loading, because, hey, this makes it less painful.
Oh, yeah. I do not use lazy loading.
I don't either.
I set lazy loading off as the default when I'm using an ORM.
Yes. And it's because it'll do this under the hood, and you're like, oh, I'm just hitting this object, but it's like, oh, it's opening up a network connection and getting the object and rehydrating it and then handing it to you. And that's a completely different operation. The other thing is that because you're working with a copy of the data that's in the database, like say, for instance, okay, you have a form, you load it up, and you say, and you've got some drop-down list of possible options, right? You put them in there in the drop-down list, and it's got the ID in the text, and it's on a web interface. So that renders to the client. The client sits around picking their nose for 5 minutes. In between time, the DBA deletes one of those options. Now, when you save, you've also got, in addition to just checking the values and making sure, hey, all the business logic is here, you're going to have some way of handling what happened if that one of those options isn't there anymore. Because now you have a foreign key constraint issue, and you don't know it until you try to commit. And if you think you're doing table reads and writes, it's really easy to miss those.
Yeah.
Let's say you're doing a complex transaction with a unit of work. So you're creating a person record and their address records, and then, maybe filing an order, and there's order details, and then there's, removing stuff from inventory, and you're doing all that in one thing. And you've got one of these partial models where you've got, instead of an object that you're pointing to an ID.
Yeah.
So you get that little round trip thing going that I was talking about earlier. Guess what happens when you're doing that? Well, to get that ID back, you're having to commit.
Right.
You have implicit transaction semantics on that unit of work. So you've committed part of what you're doing, and you get a little further down, and you get an ID, and you commit part, and then you get an ID, right? And then something blows up. Now you have orphan data.
Oh,
you have partial commits because you're trying to do OOP over here and not rolling up all the stuff and pitching it at the database at once. Now you can deal with this with transactions in your code too.
Yeah.
But what happens is most people just keep adding more crap, and they don't ever put the transaction wrapper in there to keep that from happening. Because you have multi-level where you commit, but that transaction could get rolled back if the containing transaction fails.
I can see that.
Yeah.
Yeah, I can totally see that. And
it's easier to do it than to not.
Yeah. I mean,
especially with implicit network calls.
Yeah. No, I mean, one of the things I like about ORMs is that I can set up the mappings so that I don't have to do that, and it does wrap it all up and send it at one time.
Right. It does, as long as you're not relying on going, hey, .save changes because I've got to get an ID into this thing that I'm going to copy into this other object.
Yeah. Like, I know.
Like if you do it competently and all the people have been competent, you're fine.
Yeah.
But if any of the people have been incompetent and you're having to deal with it, you're not fine. You're very not fine.
Right.
Which really sounds like a numismatic grade. It's like, I think there's good, there's very good, there's fine, very fine, extremely fine, near proof. You can tell I collected coins for a while. So that's bad enough with the foreign keys. The other thing is that ORMs try to use object-oriented principles to improve access to the database. They aren't typically written with a particular database engine in mind. So your database can vary widely. Like most of your ORMs will support, they'll support like SQLite, they'll support Access. You'll occasionally get one that still supports FoxPro, may it rest in peace. And then you'll get ones that support like, full-on Oracle enterprise level stuff. And it's the same ORM. And this can hurt you in your code quite a bit because you're basically going to have to work with the lowest common denominator unless somebody spends a whole lot of time on this, which they don't because they're writing an ORM so that they don't have to spend time, hence the pre-built tools and all. And sometimes this can have a lot of performance implications. And I'll give an example. SQL has got a thing called a hierarchy ID. And so what I can do with that is I can basically say this row is under this other row. It's a child of it. And there's a data type for that and operations you can do to say, give me all of them that are under this. Your ORM doesn't handle it. Entity Framework doesn't handle it. So when I'm making a call to SQL and I'm trying to get all the descendants of some particular node, what's the default way you do it? Well, you can make a stored procedure call and the stored procedure does it with the hierarchy ID, which is what I would recommend. Or you can say, well, I can't use hierarchy ID. You're going to have to put an ID on here for the parent. And we can do a self join, which means that, okay, I got this object. Let me get its children. Well, let me find all the children. And then for each of those, I'm going to have to make a database call to get their children and keep going until I get to the end of that graph, however deep it is. So you think about your algorithmic growth rate on that is horrendous when it would just be a call to get the thing back.
Do they have hierarchy IDs in Oracle?
I think Oracle has probably got something like that. I mean, Microsoft, a lot of their cooler stuff, they tend to lift from other people, so they probably lifted it from Oracle. And the other thing that'll happen is some of your database structures, like if you're using Postgres, you can have table inheritance in there. You can't do that in SQLite, so your ORM can't support that. And so there's a lot of little hacks and things that can get you a lot better performance that you're only going to have if you have something specific for that database. Whereas the ORM is going to typically tend towards being generalist. And that can hurt a lot. I mean, abstractions leak and they take time.
The benefit with the ORM is if you need to crank something out really quick.
Yeah.
Yeah. You just to knock it out, get this out there. That's what your ORM does for you.
Right.
It's the lowest common denominator. It's going to do the basic work you need done, and anything advanced, it will help you by not making you deal with the tedium of the boring stuff.
Right. It's just when you try to push past that and do what it doesn't do well. Like for instance, like a left outer join in Entity Framework link is ugly. I freaking hate it. I try to never use that because, the language is, like C# as a language really doesn't have that concept. The joining thing is not really built in very well. Mm-hmm. There is a join keyword and you can do some things with it and you can do inner joins. You start doing outer joins and cross joins and things like that. It gets very unreadable very quickly. And so you're also having to deal with the lowest common denominator in terms of language semantics.
Yeah.
As well. And so it's a little bit painful. What you can really do though, is you get by with the lowest common denominator most of the time, which is probably what you do. Mm-hmm. And then you say, okay, for the places where I need the extra performance, I'm going to make a call to a stored proc, or I'm going to make a call to something else that gets me what I need, the way I need it.
Exactly. As we've stated, your ORMs typically make querying a lot easier. Easy queries are nice, but they can lead to problems when the fields being queried are not indexed appropriately.
Right. And there's no signal in your code for that, right? Like if you've got a person table, right? And it's got a spouse ID that joins off to, it's a self join to that same table. But if that ID is not indexed, there's nothing in your C# code to say, hey, don't query on this. It's just there. And what ends up happening is you propagate that out to the UI, you test it on your dev box versus, 1,000 records, and you're fine. Ship it to production, make it capable for handling healthcare for the US.
Yeah.
You're going to have a bad time because you do have to have appropriate indexes built up, and you don't have that visibility as an object-oriented programmer for that stuff typically. Now, there's ways that the ORM could do that, but they don't, as far as I've been able to tell. So there's the whole thing about a field being, where it should be used. But the other problem is you tend, again, to be working directly with the table because that's the easiest semantics to work with. Well, where I work, we have clients that have got, some of them have got over 500 million documents that they've got metadata stored about, in a table. I mean, that's pretty common. And you think, okay, well, you're going to have to index it. So, okay, what do you do? Okay, they want to query on this, index it. Well, there's stuff writing to that, and that slows down the write performance. And that write performance is potentially happening, like that table is more write heavy than it is read heavy. It's an archival / compliance function, for reading that table, whereas writing it is real time. Hey, we're printing documents. And so it's got to be fast. Otherwise, there is a $1 million printer sitting idle with a staff of 20 people standing around going, I don't know why it's so slow. So you can't put indexes on those things. And if you're reading and writing directly to a table, you're going to come at, as you get to enough scale, you're going to come up to a point where you either lose out on the reads or the writes. Like one of those two things, you're going to have to make a decision. And it's probably going to be one that you make hurriedly in response to something breaking. So, I mean, that's a pretty ugly, pretty ugly place to find yourself.
Also, there's typically no way to tell at the ORM level, whether a field should be allowed to be searched.
Yeah. And I'll give you another example for that, right? Like, you have different search operators. Mm-hmm. So you've got a query builder type thing. We have one that we use. It's JavaScript. It's got some funky things in it, like it can write its own data that it can't read, but whatever. Personal pet peeve of mine that I had to hack around every time I mess with a thing and have to remember what it is. But it's got different operators for different types. Like if it's integers, you can say, okay, it's less than, greater than, equal to, yada, yada, yada. If it's a string, it contains. Mm-hmm. Yeah. Let's talk about contains and a string hitting a database. You don't want that, more than likely. Like you might be okay with it if you got full text indexing and you say, hey, it's got to be, they got to type in at least 7 or 8 characters. They got to type in a chunk.
Yeah.
What's bad, though, is when you go, okay, I'm going to make this field available with contains, and somebody starts with your system brand new, and they can type A, and they get a quick response. Because, hey, they only have 10,000 records in there. They start typing. It's even better with, the drop-down text deals that you'll see on the web.
So to make this work better, you'll need to actually communicate with your DBA or learn how to determine which fields are properly indexed yourself.
And I typically do the latter. You have to do the former.
Yeah.
Because I'm kind of I do a lot of things. And so I get pulled into the DBA role probably more than I should.
Well, when I first started, I had a lot more access to the database, at least in dev. And then the DBA kind of looked over what I did and promoted it to test.
Right.
But other senior developers,
the Dr. Evil, air quotes.
Yes. Ruined that for the lot of us.
Yeah.
And that happens where people they're either trying to learn something new or they really don't know what they're doing when it comes to the database and shouldn't be allowed to have that access.
Well, and a lot of developers are intimidated by the database. Like they don't know what happens when a query happens or like what goes into an index. Mm-hmm. And so as a result, like you do something and you change some little piece of code and the performance wildly varies. It's like black magic to them. So of course they don't want anything to do with it. They're freaked out.
Yeah. No.
So I mean, I get it.
Also, it's best if you can get the actual SQL being executed, as many database engines have tools that can let you see what the code does when executed. This is really cool because there is a thing in Hibernate in the settings where you can say, show me the SQL.
Right.
Show me the SQL.
It's show_SQL.
Yeah. Yeah. You set that to true.
In the main config. I know that one.
Yeah. And then there's another one that is format. You set that to true. And so it actually formats it.
Pretty prints it.
Yeah.
Yeah. You know what I do in Entity Framework? Because I've got an old Entity Framework.
Oh, what's that?
I start a database trace. And then when it comes in, I copy and paste it, and then I have to clean up the code and put it into SQL Management Studio, and then I can run the query plan analyzer. Once I have the query plan, then I can look and say, okay, this thing is joining on something that isn't indexed, because you can see all the table seeks and all those kind of things happening.
Finally, you have to be careful to avoid allowing certain kinds of searches. And Will's already mentioned this with the string.contains.
And there's other things too that will bite you depending on how the ORM works. For instance, in SQL, if you do a SQL function call in a where clause, in line, a lot of times SQL can't optimize that because it doesn't know what's going to come out.
Yeah.
And what the range of those things are. And so it will have really, really crappy performance. Whereas if you had just done the function call in a select or, done it some other way, it wouldn't.
Mm-hmm.
And this can be really tricky when the ORM is doing stuff on your behalf because it's thinking expression trees, right? It builds up an expression and then dumps it to SQL and SQL goes on its merry way. But there are equivalent expressions in SQL that have very different performance characteristics based on the way the indexing works. And so it's very hard to optimize your C# code that generates your expression tree that generates your SQL and make that SQL be optimized. It's like reaching up the exhaust pipe of a car to repair the engine.
So did you hear about a proctologist? Proctologist, he retires. He decides, I want to learn how to work on cars. He goes through the course and he gets to the final. It's like rebuild an engine, and he finishes and the instructor goes, well, you did a really good job. You built that engine really well. He's like, first time I've ever seen anyone build an engine through the exhaust pipe.
Yeah. Yeah. I thought you'd like that.
Yeah. So ORMs are typically used to get up-to-the-minute data from a database.
Right, because, again, that goes back to that whole table bias. It's, hey, here's the table that stores this, whatever this thing is that I'm working on. And this isn't really a characteristic of ORM so much as it's a bias in the way that documentation gets written for ORMs. It's like, hey, just get the thing out of the table. That's cool until you start getting under load. Most things in a system that is, heavily optimized for reads, do you actually need it up to the second? Could your data be stale by a minute and be okay? We have caching and we have those kind of things, but you could legitimately have it where, the data gets processed in the database and, data that's essentially in transit, you can't read. And then it's written to some storage that you can read, on 1 minute intervals or something, like that sort of thing is potentially possible, right? It doesn't hurt your app, but it makes it way easier on the database administrator to manage those things. I've seen some setups that try to mitigate this where they'll have the same data model in multiple databases and they'll have a replication scheme going on. And so you can say, hey, I want to get this out of live and use that connection to get it. Or I want to get it out of one that's, hey, this is up to, an hour stale. Mm-hmm. Or this was a day old data. And they try to push it more towards the older ones because then they're not hitting the production OLTP database. So they can hit, and the other thing is those newer structures could also have a whole lot more indexing because they're not being written to all the time.
Yeah.
It's just a bulk. Okay, here's some data.
Yeah, and I know we do this with some of our reports where we create materialized views that update once a day because there's so much data going into them.
Right, and this is like a lightweight version of an actual data warehouse solution. Like where you're copying it off somewhere. You don't need up to the minute. Right. I mean, and they've done this. This is what's happened to us with our podcast, right? Like on Blueberry. When we started, we could refresh and we could say, hey, there was, we refreshed a minute ago and we saw this and somebody downloaded an episode and we could refresh and we could see that happened. And then they got to where it was like every 6 hours or something stupid, which was not enough for the app because it's like, hey, I can't tell when my main downloads are coming in because you don't give me any other stats on what time of day. Like at least let it be once an hour.
And they kind of have gotten to that now.
Yeah, and they have like a deferred execution thing, and it mostly works. I have some suspicions that it's not perfect.
Oh, yeah.
I think it's probably about every 2 hours, to be 100% honest. Mm-hmm. But it's tolerable. And the reason is because if they're constantly writing to that data source, they don't want you reading from it because you're locking it.
Yeah. So on the other side of this, there are times that you do need to get up to the minute data.
Right, like you just committed, you just saved a sale. Now it's like, okay, here's your confirmation ID, right? Mm-hmm. And that's this typically goes back to the way people lay out their workflows.
Yeah.
Now, that said, what you could do is you could say you'll be receiving an email shortly with that.
Well, yes.
And defer it.
Yes and no, because Well, for that instance, yes. But say where I work, we write a lot of permitting apps.
Right.
And the application is a legally signed document.
Right.
And they want to be able to access that immediately after clicking submit.
Right.
Which is generated through a report because it goes through. And so that needs to have direct access. Now, it's not a lot of those.
Yeah. I would say on that, in some cases, you could actually probably get away with saying, hey, it's a minute old. And you say, hey, we're preparing this for you. And you make them wait a minute and then hit it. And they're not hitting, it doesn't take a whole lot to take load off the database. Like if you say, hey, my data can be 30 seconds stale, you'd be shocked at how much of a difference that is on a normal, OLTP database that's getting hit hard. Just because what happens is when you try to read something and if you're not careful about the way you're doing the reads, like you say, okay, I want to read this record, and the database's assumption is hey, I have this connection open. They read this record. They're probably reading it into memory, and they're going to change something. They're going to write it back. Don't let anybody else touch this right now.
Yeah.
Right. And so when you have that sort of setup going on, if you say, hey, I'm going to read from something that allows me to be stale instead of hey, I'm reading to write, you can get away. You can scale out a lot more because those writing processes are not running into locks.
Okay, I kind of see what you're saying. We don't really run into that much load.
Right.
On the permitting side of things. Now, on some of the other areas, we do have some load, but on that where we need those, at least on what I've worked on so far, where we need that printout, that report immediately after they click submit.
Yeah.
We are not on things that are going to be under load.
Right. Now, whereas some of the systems I've worked on had really spiky load problems. So, like for instance, we had content systems for news stations. Mm-hmm. 260 some odd news stations on there, most clustered around in the Southeast U.S. Yeah. Right. What happens in the Southeast? Okay, we have snow. Everybody and their mother goes out and gets in a car wreck, and everybody and their mother takes a picture.
Yeah.
Or a video, and it's got to go processing through the system, right? So it hits. We have like flash snow. We've had some of those where it's, it's like it looked fine, and then all of a sudden here it is.
Oh yeah. Well, and those of you guys from the northern United States and countries where snow is a regular thing, you have to understand those of us from closer to the equator.
Yeah.
That,
people can't drive in it. It also...
We don't have the infrastructure because it happens once every 5 to 10 years, and it's pointless to...
And people can't, people can't drive in it. People don't look at the sky and go, hey, it looks like, I need to get going. Uh-huh. They go, I can wait 5 more minutes. And so you have like a mass panic. But the other thing that this leads to on aggregate is sudden spikes in traffic. Now we had a setup where we could scale out our servers, through rack space and all that. And you go, hey, I need to go from, 4 servers to 30. But I think it took like an hour. But in between there, you have this huge spike in load that you have to keep from breaking the system.
Well, that's one of the things that infrastructure as a service, such as like the cloud service providers, have helped mitigate because, it's just a dial to ramp it up, or you can set it to automatically do that. The problem with that is things like you and I, we got burned on that.
Yeah.
Where it was a default setting was set to ramp up, and we got a spammer attack.
Yeah.
And it ramped up without us knowing it and ended up costing quite a bit of money.
Yeah. And that can happen. But this is the other reason why you have a lot of systems like your document databases. They're not ACID, they're base. And so they're eventually consistent. And usually eventually is like seconds, right? It's, unless you're under a crazy load, but it can scale out and be an hour. Mm-hmm. And, it makes it survivable with cheaper hardware. Because that's the other thing. You're at the state. And so typically they're going to go, hey, they're going to do planning and they're going to purchase the amount of stuff. Whereas you get a startup that has explosive growth, and particularly if they start out with commodity programmers early on, like you may not be able to pay to scale that. So that's why this gets to be pretty important.
So in closing, it's probably better to stop thinking of your database as a data storage system and instead think of it as a microservice that happens to be written in SQL. We mentioned that a couple of times already. By thinking of your DBA as another developer who writes a service that you're consuming, you'll be better able to make decisions about how to use object-oriented principles in your application. While this is sort of a subtle shift, it's one that you need to make as a developer to make it easier to work with your DBA and just have a better work environment in general.
Yeah.
That pretty much wraps us up. Before Will gets into tricks of the trade, we want to invite everyone in the Nashville area out to Barcamp Nashville Conference.
Barcamp Nashville is a free annual gathering of the local tech community to learn, share, and connect.
Yeah, it's a day for sharing your passions and discoveries and exploring new interests.
Barcamp is a user-generated unconference allowing anyone to participate as a presenter, organizer, or volunteer.
It's an opportunity for those who found success and failure to share their experiences and learnings with others to help grow and strengthen the Nashville tech community.
This year it will be held October 21st from 8 a.m. to 5 p.m. at the Tech Hill Commons. That's the same building as Nashville Software School, by the way. There will also be an after party.
Yeah, Will and I, along with the Junior Developer Toolbox crew, will be there at our booth and also recording interviews in the podcast lounge. Follow the link in the show notes to register and vote for the talks that you want to see. So, Will, what do you have for us this week for Tricks of the Trade?
Well, I've got a little trick, and I think this is something that's a little hard to do with your traditional ORMs, but basically the idea is if you have a primary key or foreign key field, is instead of saying, hey, this is an integer or a long or whatever, actually make a custom type for it. And that custom type can wrap, an integer or a long, if your language will let you do this. And what's neat about this trick is then if I have let's say I have a person table and I have an address table, our canonical example, I can instead of making the person ID a long integer, I make it a type that wraps a long integer. Well, if I screw up and I try to put that into the address table, it's got an address ID type that is not compatible. And so I'll get a compiler error based on the type system. Even though the underlying structure is the same, you can actually use your type system to avoid certain kinds of errors. Now, this can take a little bit more work as you start dealing with things like stored procedures and the like. But don't ever forget, you are doing OOP programming. And if you use your type system, you can get away with a lot more than you've probably thought about using your compiler and your type system to protect you. Bear that in mind. That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Look for us each week on Facebook Live before we record each episode. Thanks for listening. See you next time.